Okay, welcome back. We've got another video on our Smart Servo robotic arm. Up till now, we've worried just about the positioning of the arm itself, and we know that um, if we run the servo subscriber node and publish over the topic servo, we're going to get the servo arm to do something. Now, if that servo message comes in the form of a directive like home or reach or wave, then those of course come from the main subscriber, then it's going to do those things. If, however, the main subscriber sends a message over the OpenCV topic to our OpenCV subscriber and says find, it's going to go to this node. This node will be running. And when we get a find, it's going to run this callback. Now, I'm not going to go into great detail about what's going on here. This is some pretty standard code that's available out on the internet. But we read the data from the webcam. Then, and by the way, I put some wait keys in here so you can actually see it happening as we do this. Um, we can take those out later if we want the arm to move much more quickly. But we turn and we go ahead and look for an object. We look for all the objects, and then we try to find one that's pretty big. So we don't want a little speck to give us a position. And once that gives us a position, then we need to use the X and Y values coming from our webcam. Now, this is where it gets a little interesting because we don't want to send the webcam X and Ys over to the servo. Rather, we want to send X and Ys that make sense to the servo. So these two conversion factors here are there for that exact reason. So let me show you how we calculate those. Let's go back. So as I noted the last time, this is the top numbers are what we would get from the webcam. The bottom numbers are what we want to use for the servos. The webcam, by the way, is down below. The servo is up above. So all that makes a difference as we do that calculation. So to make that calculation, if we're going to go from the webcam to the arm coordinates, we're going to subtract an offset. We're going to create a scaling factor, and then we're going to calculate that new value. If we want to do the Y values, we do roughly the same thing, but it's a little different just because on the Y values, again, the X values might look the same, but the Y values are going to look a little bit different. It's just based on the webcam is located. So in the end, we can do those calculations. Here's the X locations. Here's the Y locations. And so we can do those calculations. And then what we can do is send a value over to the OpenCV servo. But let's try we're going to look just at how we run the find, just to see how that might work. So let's go ahead and look at that and see if we can't get something. So let's go ahead, and I've got some values here that we're going to look at. So some screenshots I took. Let's go ahead. This is one that will tell us. So what we're going to do is down here, we're going to run the OpenCV subscriber. And then up here, we're going to go ahead and say, send to that, we're going to publish on that topic the find command. And then when we do that, we're going to end up with this picture. So initially, we're going to take a picture of the webcam. This shows the contours we found. This shows the one it thinks it wants to find as far as, hey, that's the one we want to position. And then finally, we're going to want to send that position. So notice in this case, I've sent several find commands, and each time I've moved the chess piece, each time it's found that and published over the servo topic the position of that object in terms of servo, not in terms of webcam. So that's what we're going to do to get everything to work and get to a point where now we've tested just the OpenCV subscriber. We know it works. It creates finds our chess piece, gives us back the position, and sends that over to the servo.